On homework 8, you have a few questions that are going to give you a chance to practice labeling or identifying glycosidic bonds in disaccharides. And so here's one, it's giving you a disaccharide, and all it wants you to do is choose what type of glycosidic bond you have. So how are we going to go about doing this? Well, first of all, you know where the numbers come from. The numbers are coming from the carbon atoms that are connected together in the glycosidic bond. So what you need to do is number the carbons in the ring, go around the ring. And you know, I can stop there if I want to because I don't need to keep going. So this is going to be 1 and 4. It's either going to be this guy right here or this guy right here. I can eliminate 2 answers right away because I know it's a 1-4 linkage. And that's the easy part of this. Now you have to decide if this is an alpha or if it's a beta. And, you know, you got a 50-50 chance. But the way that you're going to do this is by asking yourself, was or is, not was, is this an anomeric carbon? Anomeric is such a fancy word, but remember, anomeric is just referring to the very right-hand point of the ring, of its own ring. So is this the anomeric carbon of this ring? Yes, it is. And for this particular anomeric carbon, is the OH sticking up or down? Or you have to think about, was the OH sticking up or down back before it became a disaccharide? The OH is up, so this guy is beta. So for this one, pretty similar. Number your carbons, starting on the right-hand point, number the carbons around the ring, and figure out which 2 carbon atoms are coming together to make the bond, and see if you can eliminate it, because if it's a 1-2 linkage or a 1-6 linkage, you don't even need to think about if it's alpha or beta. You guys can get that figured out. What about this one? First, we have to identify the type of glycosidic bond, which I know you guys are experts at right now. And then the next thing down here, okay, so it's saying the monosaccharide units produced by hydrolysis are what? What does that mean, hydrolysis? So hydrolysis means breaking something apart with water. Hydro means water and lysis means break. So when we metabolize disaccharides in our body, our enzymes just split these molecules back into their monosaccharides. So here, this just means that we're going to break it apart. And what is it going to look like when we break it apart? That's what this question is asking for us to figure out. So to do that, let me see if I can get a cool color here. What we're going to do is we're going to go back over to our disaccharide and we're just going to break it apart. We're going to get rid of that bond. It's gone. I just hydrolyzed it. And we're going to fill in OHs. Pay attention to which way you're pointing them. You've already got, on this carbon, you've already got something sticking down, so your OH needs to go up. And on this guy, you already had something sticking up, so you need the OH to go down. So there you go. Those are your monosaccharides. Now, how are you going to figure out what exactly they are? Well, this is going to be your challenge. You can totally do it. You have those tree diagrams. You can figure out exactly what those monosaccharides are. This is a multiple choice type question, so you could probably, you don't have a lot of different options to choose from. So I know you guys can use your problem-solving skills to identify those monosaccharides. And here's one more, really similar. This, first of all, it wants you to identify the glycosidic bond, which I know you're going to be able to do. And here, it wants you to actually draw the monosaccharide units that would be produced when this guy is hydrolyzed. So we know that when we're doing the hydrolysis, what we're doing is breaking this bond right here, going away, which means that we know that there's hydrogens right here. And down here, there's OHs. And everything else in these two rings, nothing has changed at all. You haven't done any chemistry to these guys out here. So these are going to be totally unchanged from what they looked like in the disaccharide. Now, question 19, I'm not going to show you. It's tricky, but to answer that question, what you want to do is go back to your notes for, I believe, lactose. It's on that worksheet. Go through that part and you'll be able to answer question 19.